this example, we are asked to find the domain and sketch a graph of the function f of x is equal to x squared minus 2x minus 3. So first things first, we need to find the domain. Now looking up here at our given function, we realize, hey, this is a polynomial function, a quadratic function. So since we have a polynomial function, we can automatically conclude that this function has a domain of all real numbers. So now that we have the domain of our function, we're ready to start sketching the graph. Now, in order to sketch the graph of the function, we want to create ourselves a table of values here. So you can begin to see the importance of finding the domain first. That's going to allow us to check what x values this function is going to exist for. So I would recommend selecting at least 5 x values to get started. Remember that you can always go back and add more x values and find more solution points if needed. So we've taken each one of our inputs, our x values, and plugged these input values into the function to find their corresponding y's. So we now have a list of solution points that we're ready to go ahead and plot on our graph. So we can see that when x is -2, y is -3. When x is -1, y is 0. When x is 0, y is -3. When x is 1, we found y is 4, or -4, excuse me. And last but not least, when x is 2, we found y is -3. So these are the solution points that we're now going to plot on the coordinate plane. Oh, and I've noticed an algebra error in my work. In our first solution point, we have 8 minus 3, which is not -3, but +5. -1 on my test. So you have -2, 5 up here. Our next solution point is -1, 0. Our next solution point is 0, -3. We have +1, -4. And last but not least, we have the ordered pair 2, -3. So in order to see the graph of this function, we now connect these ordered pairs with a smooth curve. Now, one final note here is we can actually determine this function's range by looking at its graph. So notice down here at this turning point, we see the very smallest possible y value for the graph. So we can see that our smallest y value here is -4, and then we can have any other y value thereafter growing and approaching infinity. So this is letting us know the range of our function. We can see here that y is going to be greater than or equal to -4. And if we wanted to write this inequality in interval notation, we can say that y is an element of the interval from -4. Notice how we've used a square bracket to include that value. And then this is growing infinitely in a positive direction.